This is finding a confidence interval for a population proportion among two populations. In this example, a survey of 436 workers showed that 192 of them said that it was seriously unethical to monitor employee email. When 121 senior-level bosses were surveyed, 40 said that it was seriously unethical to monitor employee email, based on data from a Gallup poll. Construct a 90% confidence interval of the difference between the two population proportions. In this solution, we have to identify all of the given values in symbolic form. We'll call the first population the employee email for the workers. And N1, the sample size is 436 employees were surveyed. X1 is 192 of those. So the proportion of people in the first sampling said that the proportion was 192 out of 436 said that it was unethical to monitor employee email. Simplifying that down, we can find Q hat 1, which is the complement of P hat 1, and that's 1 minus 192 over 436, or 244 over 436. When the survey of bosses was conducted, there were 121 senior level bosses, and 40 of those people, or X2, said that they were seriously unethical to monitor employee email. And P hat 2, those bosses were 40 over 121. For Q hat 2 of 1 minus 40 over 121, or 81 over 121. Calculating out a 90% confidence interval formula for the difference in the population proportions is the lower limit is given by P hat 1 minus P hat 2 minus this critical value is Z subscript alpha over 2 times P hat 1 Q hat 1 over N1 plus P hat 2 Q hat 2 over N2. This critical value for a 90% confidence interval is determined from a Z test distribution. We have 90% of the data lying in the center, so that means 0.05 lying in each tail for a total of 100%. If we look up in our Z tables, we'll find out in the body of our Z table, if we look up on the left tail, 0.05, we'll find negative 1.645, and 0.05 in the right tail is 1.645 for a Z score, or a critical value. So we can fill in all of the numbers that we have, and for the lower limit, we take 192 over 436 minus 40 over 121, just filling in from the formula, minus 1.645, square root of 192 over 436 times 244 over 436, and divide all that by 436. And then we're going to add it to 40 over 121 times 81 over 121, divide that by 121. Add those numbers together and then take the square root. What we'll calculate out is carry all the decimal places. You'll get 0.109788461 minus 1.645, and then the square root of 0.00239413338. Calculating out 1.645 times that, we'll get 0.0804896641. This here is the margin of error. So all of this is 0.080489, that's considered the margin of error. So taking that, we have 0.109788461 minus that margin of error, and we get 0.029298796. Now we can calculate the upper limit in the same way, except instead of the subtraction like we did in the lower limit, we do addition. It's the same formula, except now we're adding the margin of error back in. So calculating back out, using the same numbers that we have, we'll get 0.109788461 plus 0.0804896641. And we'll calculate that out as 0.1902781242. So the 90% confidence interval for P1 minus P2, or the population proportions, is 0.0293, carrying 3 significant digits. Zeros don't include significant digit. P1 minus P2 less than 0.1903. Now, that means all we did was convert these values here into proportions that relate back to our population of those workers who have had seriously unethical monitoring of employee email. And that's how a confidence interval for two population proportions is conducted.